Hello, hello, hello. Here I am ready to go for Quest 7 of Everybody Codes. Got my code ready. Figured out how to start Wallaby on a single file and not my entire file system, so we're going to have responsiveness. So the odds are a little bit better now. Yeah, excited for day 7, or quest 7 rather. This puts about a fifth or something to the degree through. Here we go. Ooh, oh boy, okay. This is an interesting one. BDCA. Okay, I can kind of see the vision for this. Let me grab my inputs. Okay, 1, 2, 3, 4. Well, A, B, C, D is obviously wrong. Okay, let's focus on the real one. I think I need to parse this and do some stuff, but let me understand it. Cover the entire duration of the race, 10 segments. That's not going to last. Calculate the device's power for each segment. 11 plus 10 plus... Okay, who said you were 11? Oh, you start at 10 and you plus 1. Okay, so you all start with a 10 and then you just do the things. What are these equal signs? What are these equal signs? Does that do nothing? Okay, I think the equal signs are do nothing. Let's do this. Okay, so for cos align of nodes that split 9 cost node raw changes equals align dot split on that colon changes equals raw changes dot split on the comma. You know what, I'm going to leave them map C if C equals return for +1 for -1 for equal 0. C. There we go, we have these, and I guess we just go through it. Let value equals 10 or 4 blow my fingers. Changes value plus equal change, and then I guess I output total essence gained of each plan, the final ranking. Okay, it's basically leaderboards, right? Gained equals map. There we go. So gained node equals value. Return object dot entries gained dot sort a1 minus b1 smallest to largest, right? BDCA, largest to smallest. So we're going B A, and then we want map node, the nodes themselves. And what are we doing? Are we joining these together? Yes, we are. BDCA to equal BDCA. What is wrong with my eyeballs? What is wrong with my eyeballs? BCDA, BDCA. Okay, I did math somewhere wrong. Node value. A10. That's not the value. Value is supposed to equal. Oh, it's supposed to add them all together. Total equals 0. So it's. I mean, we are doing by 1, right? Total plus equals value. Do it at the beginning of the end. We do it at the end. There we go. So it's total. Congratulations, total. It's total. 41, 43. I'm not. I only have 4. I have to do this for 10 segments. Okay, I got this. 4 let s equals 0. S less than 10. S plus plus. And then I basically have to get const change I equals changes dot length. It's basically I modulo changes left. So let's move total, let's move value both up and out. And then it's do this to both. It's not I, it's S. Const change equals changes, change I. We're getting good. Okay, show me this one. Yep, those are good letters. Nice. Also affect. This is what happens. Simple the following notes. So for the sample plan and the track is. What? What? You can't just add a whole new input like that. I mean, I guess they can, but what have they done? Yeah, so part 2, you're definitely getting your own function. Congratulations, you've been promoted. On the track below, let me grab my actual input. Pretty. Okay, an actual input. Where's the track? What? I have to read this. Special tracks. The tracks close of segments. Train of track. First is executed up to the segment S. Yes, 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 yes. Example based on the notes. So for the sample above and the track is below. Does that the racetrack for the first round is shown below? Do we all have the same racetrack? I'm assuming that. I don't know. This is they're doing some stuff now. I really hope this is that. Okay, so yeah, this is my smaller racetrack. I guess that's the second argument. We'll find out. What's my answer for this one? Final rankings is DCBA with these essences gained, which I might use for later purposes. Oh, DCBA. Okay, yep, they're the same. Okay, let's try this out and see what happens. Solve quest 2. We have our notes, and we also have our map, string, or track rather. Call you the raw track, because you're gonna change real quick. Okay, is there a direction to this? Clockwise direction, to the right when viewing from above. So, this way, and then down, and then left, and then up. Okay. Can actually read this. Does not alter execution. Force the device to increase. Let's start from S and go clockwise. First is executed. Last. S is the segment everyone starts. Also the last. 10 loops of the race. The actual actions, taking into account to race track, will be as follows. So. Okay, I'm not seeing how the action of the track influences the action of the racer. But, okay, so these are the characters of the thing. Is there some kind of Pokemon system here? I mean, I have my own symbols. Like, we're all starting. Well, C and D are starting with this. Ooh, so they get overrun by the plus. Okay, so let me see. A has a minus in the next one. So their equals is do nothing. Okay, so there's a plus coming up, and the plus coming up, minus, okay, I'm seeing the verticality pattern. When it sends a signal, everyone listens to it. Okay, I got it. I got it. I need to turn this track into a sequence. Const track equals array. So it's basically, I can do some bad stuff here. It's first line for raw track split new line 0 slice 1 track push Congratulations, you're the first line. Or let r equal 0 or less than all track split new line. I guess I'll do this. It's gonna come. Nope, I don't need to do it. I'm gonna be bad. And then I need to grab the characters on the right side. Track dot push. All track dot split new lines to my current row, and then I need the last one. Slice 0 -1. I think that's how you get it, and then index 0. We'll find out. I'll look at it with my eyeballs. So that is the entire right row. I need to skip the first one though, because that's top left. Great. Now let's track.push. Track.push. Raw track. Split by the new line. Get the last one, so the bottom line. Slice 0 -1, because I don't want to get bottom right, because I already captured that in the last one, but I don't want them in this order, so I need to reverse them. But I need an array in order to reverse it, so I'll take this, spread that into an array, and then spread that array into these pushes. We are almost there. We're doing the last wall, the left wall, so our row needs to be the length -1, -2, because we don't want that bottom left one. And then r greater than or equal to 0, I think, and then you just negate the down the world. Okay, so we split by this, we get the 0th character, and that might be it. So let's look at this track and return the number 4. That's close to the number 4 in my mind. Okay, where is the one I need to focus on? Right here. Let's get Wallaby cooking back on this. Yeah, focus on the one I care about. So, first we have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yikes. So plus and 3 equals. Good. Plus plus. Who the hell did you come from? Okay, so let's start with the first line. Plus and 3 equals. Great. Plus and 3 equals. Negative equals. It's going on that side, not the right one. I have the line though. Boy, I'm spending too much time parsing this stupid track. So we have it. I just need to grab the last one, not the first one. Am I starting from the 0th? Dang it! That's not where I wanted to go. So I need to see plus and plus. Oh, I can just do that. Dang it. Boy, I have not done this in a hot minute. -1, 0. Great. Am I doing that anywhere else? I'm not. Okay, so I see my double pluses. Now I see minus equal plus equal. Minus equal plus equal minus s. Okay, we're good. We're going a little bit too high. So we just need greater than. Got it. Our 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got my track. Okay, now we need to iterate through this. And we do 10 loops. Start. Okay, so for each of them, you just go and I'll track your gain. Okay, so for basically for lap of lap for lap of, well, lap equals 0, lap less than 10, lap plus plus. And for each lap, you are starting from S, which doesn't count. So we pick out, so you do this many rounds. This many steps. Got it. So the steps, they go into here, and then that is track.length. Good. Now your action, so you have change I. There we go. Cost track change. I and just use track S. There we go. And you know what? I can just do inline mapping and transformation of this. I've already done this. Let me steal it. Where's it at? There we go. For all these, congratulations. You just turned into numbers. Big fans. Big fan. Track equals track dot map. Congratulations, you're a let. Need to reassign you. There you go. So we have that. We have track changes track S. If track change equals track change, if you get overridden by a yours truly, drop that console log, and it's not working right now. That's very sad. I am focused on the part 2. Let's just run it. Did not record. I mean, it passed. So this might be it. This might not be it. I'm gonna wait a few more seconds. Try to get Walby back online. Okay, it passes for this one, which means it's either working or it's not working. Won't know. Okay, final ranking of action plans after 10 loops. Oh, this is concerning, because it means I got something wrong here. So I can look at the track and I can look at the rankings. So let me console log gained. Let me focus on part 2. So 1190, 3640. Where? No. No. Okay, this is wrong. This has been wrong. Do their things persist? I bet they persist. I bet they persist. Yeah, watch it persist. Let gain, so I guess I'll just use that as their tracker. I mean, there's no reason not to at this point. So for every line, yeah, total. I am doing it outside though. They are persisting. Okay, I kind of need to just visualize and just go through one, I guess. Only have one round to look at it though, so the console log node change. It's gonna be a lot of them, but that's okay. Let's do my conditional in here. If lap equals 0, then you lock this. I don't want to see everyone in the universe. There we go. It's just a number of A's. So 1, -1, 0, 0, 1, 1, -1, 0, 1, double -1. Dang, that's what happens. Ooh, you actually ran on the S. Oh, which means track length is track length plus 1, and there's an S in there that I ignore. Okay. Track, not trash. Track dot. No, what is going on? Track dot push. I'm just gonna call you an equal sign. So 1290, 3640, 3700, 4280. There we go, baby. Now I got only like 3 more minutes, so that's unfortunate. Excuse me. Hi. Is this the exact same? This can't be the same. Uh-oh. Okay, I did not find enough in here. Hello? DCBA, which I got DCBA. So my track parsing could just be wrong. Let's focus on this. We can target that. Yeah, please stop looking at that. Okay, so let's just look at my track. Boy, there'd be a lot of symbols. Let's start with the first line. So I start at a negative and I end at a negative. I ended a double negative technically. Okay. Let's look at the next characters we're logging. Which is negative equal plus equal negative. Uh-oh, it looks good. That's not what we want. We want it to look good, but we want this to be where our problem is. And this is our left side, so negative equal plus equal negative. Dang it, okay, this is our bottom. From right to left. Plus equal plus. Dang it. And then we end in equal double minus. Oh no. Oh no. Here's the one thing. I am resetting after every lap. I'm getting the right number though. Let me reread everything. Knights start from S and proceed in clockwise. I did the parsing. The terrain is exact same. The last action at the S segment, last segment. The race is set for 10 loops. Examples based on the notes from the sample plans. The actual actions taking into account. Yeah, when they have a symbol, you do what the thing says. Okay, when we look at these equal signs, are there any patterns here? So B, C, D all have plus on that row. 0, 1, 2, 3, 4, 5. No, 1, 2, 3, 4. 1, 2, 3, 4. Yeah, y'all are plussing on that row or column. Equal negative plus equal negative plus equal negative equal. Okay, did I copy in my newest input? Maybe that's where I goofed. I did copy it in. No. HBDI. I already pasted. If I break this, it'll break. Well, it's the last character, so. Okay, let me just completely ruin this. Okay, I was about to be a paranoid. Okay, what is the final ranking of action plans after 10 loops? The racetrack is shown as below. For the first round is shown as below. Yeah, this is the only thing that I really got confused about because we're not being provided a racetrack in my input. Is there not? There's none. Is the racetrack being magically derived from this? Plus triple equals. Plus equal. I'm not seeing it. The racetrack for the first round is shown below. Why is it saying first round? Does something change the racetrack? Oh boy, I'm getting stumped here. It's my reading comprehension that's stumping me. Gonna try something, see if it works. Drop that, unfocus it, because it's not helping me at the moment. My total is already in there. Okay, let's imagine we put those in here for some reason. I don't know. Yeah, I don't know. I'm not comprehending what I'm missing. Yeah, I copied it correctly. Action plans after 10 loops. Yeah, 10 loops is what I did here. Oh, this is a problem. I mean, I knew I'd eventually hit some problems that I would not be able to solve completely all parts, but then at least for everybody codes getting to the next third or fourth week, I might as well, I'm waiting for something to hit me, unfortunately. reread everything. Essence that can be pre-plan starts with 10, executes an action, track length is 10 segments, which isn't anymore, it's length of track. Does S do something special? So equals triple plus. Equals triple plus. It doesn't do anything special. I could be getting the right answer with the wrong wraparounds. 1, 2, 3, 4. Okay, I think I see what might be going on. Like, I use what actions I have, but then, like, it doesn't cycle these properly. Okay, let's go on that theory, that I just mathematically stumbled into the correct thing. Yeah, okay, so let change I equals 0. Then for each thing, congratulations, change I plus plus. If change I, stay with me, Wallaby, greater than, change I rather, drop that. If change I greater than or equal to change length, I think it's -1. Change I equals 0. Change I, come on, figure out my keys. Okay, I don't think I'm just wrapping at this point. And I'm also moving it outside, so I could be doing the wrong thing. Let me see. Change I. I need to see more information, I guess. Node. Come on, show me. So A 0. Oh well, we already skipped 0. That's our problem. See, once you have the change, then you increment, you idiot. Come on. 0, 1, 2. So we're terminating very quickly. Attacker changes again. They're an array of 4. Oh, please, let's focus on mine. 0, 1, 2. 0, 1, 0, 1, 2. Do we never hit 3? What's up with that? Why do we hate 3? Are we allergic to 3? We're allergic to 3. Greater than? What have I done? Oh, there we go. Okay, we're hitting 3, and we're calculating. Okay, maybe this is what we need to do. Drop those, drop those. I mean, it's outputting the same, so I can't tell if it's better or worse. But I can unfocus and see if the H blah, 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 blah changes. Ah, that looks very similar. Don't give me that. Give me that. It changed. I got nothing to lose. Boom. Okay. Okay. Knights must make their action plans. 11 actions long. Oh, geez. The duel is set for 2024 loop. Oh, I was supposed to do real parsing. I did. Never knew that. Wait a minute. Consider all possible plans. Oh. 5 pluses, 3 negatives, and 3 equals. Ooh. Okay, well, this actually does limit it down from whatever that is, factorial, to that. Ooh, and they give me no example. Making me sweat. Okay, let me at least celebrate my victory here. Ay. Okay, part 3. No example, so I'm just winging it. Solve quest 3. Might as well give me my input. Man, what the heck is that? Oh, so this is my rival knight. Okay, good. So there's a way to calculate this. This honestly doesn't seem that bad. I mean, 2024 loops a lot. So I just need to generate all possible valid, what you call it, and filter by all the ones that give me a better score than the one I'm given. I'm not liking this because I have to use real parsing thingamabobs. It's painful, but we're gonna do it. I don't have an example, so let me stop delaying and actually do the thing. No, not paste there. Okay, quest F3. So I guess we'll just do the easy part. Boom. Okay, we're done right now. We're not done. So this is my traversal bit, which should be perfect. I just need to run it for every possible iteration. So we have the track. We do not have a track. Okay, so function parse track, raw track. Yeah, you're getting your own function, little buddy. So basically what we need to do is for every character we'll do this. We will start here, we'll go here. So this will be our initial path. It'll be 2 nodes long. And then for every, basically until we hit this S, we're just going to look in all cardinal directions, find the one that's not where we came from, add it, and go, and go, and go, and go, and go, and go, and go. Okay, so let's say cost path equals, it's an array, R0, no, not R colon, R0, C, 0, what are these? S. And yeah, you'll be the S for now. I'll replace you with something cooler in a moment. Drop this, drop the next one, which is R0C1, and then I have to pull that one actually out. Raw track. Well, it's literally the one character. Congratulations. So while path dot at -1 S not equal S, you're gonna keep looking. Cost RC equals path at -1. Many more cheaper ways to do this, but for our let's break this down. 0 1 0 -1 1 0 -1 0. All of our cardinal directions cost NR and C equals R plus ROC plus CO. Let's make sure we're still on the world. So cost world equals raw track split on those new lines. Let's use the world when we can. Whoa, not like that. World 0 0. Yep, just gonna do that. Cost segment, well, cost, no, car equals world NR question mark dot, because it could be off the universe, and C if not car or car equals space. So yeah, if you're any of these and you are bad and I don't want to look at you, continue. But if we're going backwards, we also don't want to look at that. So let's do this math up here. If NR path cost previous equals path at -2, and yeah, I'm using a lot of array accessing here. It's fine. If root R equals NR and prove C equals NC, then yeah, also ignore that one. Ignore that one. And hey, congratulations, you just found one. Path dot push R and R, C and C, car, well, S is car, and continue. There's only ever one direction to go. Stop looking in other places. Term path. Let's see if that worked. So I mean, it's a path, not a track. Do I need the coordinates? I don't need the coordinates. Path.map p.s. Give me that symbol. And you know what? I'll keep that for now. We know this track is useless. Let track equals parse track raw track. Now let's see if with our eyes we're at least following it. I love that. You can't go backwards, Bubba. What do you think you're doing? What are you doing? If previous R equals new R and previous C equals new C, continue. You're going backwards, little man. It's illegal. Wow, the latest one is not S. Oh, did I just... Oh, that's on me. Okay, now we have a path. S plus equal S. S plus equal, and then you just teleport. That's cool, I love that. Okay, so keep going, Quokka. I love you. Row 0, column 0, row 0, column 1, row 0, column 2, 0, 1, 2. That's where the equal sign is. Row 0, column 0. How did you teleport? Tell me how you did that. That's impressive. You're teleporting on me. Console log and R and C. You did it. So you went to 0, 2. That's good. Path.push, that adds to the end. Console log RC. Sure, I'll bring out the S just to look at it with my eyeballs. Yeah, RC. So yeah, we're at the plus and da 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 da. We found the equal sign. Good job. Oh, you're supposed to break, not keep looking. There we go, and now filling up my console, which so please not. I assume this is correct. I'm gonna look at the track with my eyeballs. Hello. Give me the check. Okay, there we go. So plus equal plus 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 equal 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 negative. Plus equal plus 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 equal 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 negative 5 pluses. 1, 2, 3, 4, 5, and then an equals, and then a negative, and then a double equals and a plus. Okay, I have the track. And then I transform the track. Big fan, big fan. What about that S? Congratulations, you just got turned into a 0. We were very happy for you. Okay, so now I have this. First I can make sure I run this and I generate a gain for our racer. Woo woo woo. You did very good, racer friend. I don't know if that's accurate or not because I don't have any examples, but it's okay. So now I just need to generate all possible valid, whatchamacallits. Try and optimize for generating good ones, but I don't think I'm going to do that. I think I'm just going to brute it. So cost the hell valid plans equals generate valid plans. Yeah, we're just doing another function. Valid plans, and what are the rules? 5 pluses and remaining 3. So cost pool equals plus 5 negative 3 equal 3. So I'm gonna do some bad stuff. Oh, combinations or permutations? Ah, jeez, I always love this. Of the values in array in JS. No permutations. Okay, let's see if we've got adding a move version. Sure, I'm just gonna take this and see if it does what I want before I go using it. console log parameter CAT. Don't give him a now, Wallaby. Doesn't like me. What did it do? What did it do? Oh, too many things. Okay, there we go. Undefined. Oh, it says it. Are you modifying it in memory? Is that what you're doing? How do I get access to that? Oh, that's a whole function. Oh, whoops-a-daisy. Okay, so I have cat, CTA, ACT. So what I want to do is I want to watch that the duplicates are... Geez, show up. Okay, great. Yep, so we have our duplicates. As anticipated, I will ditch those in my own bit. Turn result, which is just literally everyone we've ever seen. Sure, I'll suffice with this. It's not efficient. It's not what I really want, but it's cool. Cost array equals... Well, it's not an array. It is now. Permute array const all possible equals congratulations, or it's pure permute. Very cool. Let's drop you in a set. Get rid of all them dupes, and then put you back in array because I don't like that. Return all possible. How many you got in here? Am I calling you ever? So either you're doing something and you're really chonking, but permute is not defined. That's an old one. Yeah, I think we've just hit writing computational lists now. So I'm going to tell Wallaby to hold it. And generate valid plans. Console. Valid plans. Here we go. Let's hit it. Show me numbers. Ooh, you're doing a lot of work. I don't like that. I assume you didn't hit an infinite loop. I mean, it doesn't feel like a lot, but I can see how it can be a lot. We're also not getting rid of the duplicates until we already see them. So result equals, let's make the optimization, new set, result, add, but M is an array. We don't want that. We just want a thing of characters. M plus next. Congratulations, you're an array of characters now. How did you make M? Who called you with your first thing? If array length equals 0. No, that's not how you got here. Yeah, you did. You get me. Oh, that's not efficient. It's okay. It's okay. It's okay. Yeah, we hit our limit. I could see that, buddy. Are you better now? No, you're not doing better now. Okay, I might need to break this out of testing land. Steal all my functions. All the functions, come with me. No new folder. Actually, it's sufficient enough. I'm still gonna take you out though, because I have more iterations to run, and you're not surviving. Drop you here. Copy you here. Console log you, drop the to be or not to be. Get my terminal out. Ooh, okay. I mean, hey, it's less than 10,000. We can brute force this easily. npx_tsxq. Hit it. Parse track is not defined. I brought everything over, I thought. Dude, how did I even fail? I was loaded one function short. Get over here. Yeah, goof. Oh, okay, it's a little hard there. Okay, I'll make it a little bit of improvements. We already have a set, so don't do that. Just give it to me. Just give me the set. I don't care that we don't need to retransform it and transform it and untransform it. Congratulations, just shove that in there. Yeah, we're gonna keep doing the bad stuff here. There's no way around it. Okay, so we have to basically add every single one as a participant. So, and the nodes are arbitrary. So, on the nodes, they add the thing. So what we want to do is for let I equals 0, I less than valid plans dot length, I plus plus. We want to be like, oh, sorry, are you a size? Oh, jeez. Oh, jeez, you're not. Valid plans dot, yeah, I'm not going to access anything with an I, am I? Wait, what the heck is that? Is that? Oh, yeah, I was about to be. No, wait, that's. No. Congratulations, your set of strings. The heck is R? Yeah, no, you can't do that. So let node equals 0 for cost plan of valid plans node. Congratulations, yeah, do the thing. Then what we do is we say notes plus equal. I guess we start with a new line. Doesn't really matter. We're just doing the badness anyway. We add one more, and then we say note colon, and then the plan node. Oh, sorry, jeez. There we go. And then we have a bunch of them, and then you just do your thing, buddy. And I'm gonna want to get out the best game, so we're dropping that log. Is it the best? Still the best. How many different winning actions plans can you refer? Okay, so once I have you all, I need to track how many are winning. Okay, this is kind of doing not really what I want then. Nope, let's not do that. Cost to beat equals object dot values gained 0. Okay, so now we're just gonna do this again and see how many you beat. We're just gonna do it again. Don't worry about it. For cost plan of generate valid plans. For cost raw changes of this right here. Love it. And then yeah, we have our raw changes. Your array of strings, you idiot. You idiot. Okay, you're a set of strings. The same. Changes. If I want to be more or less. Okay. If total greater than 2 beat cannot be a number unknown. You're a number, you idiot. Love that. GTE. Else if total less than 2 beat LTE. Well, it's not E. Else E plus plus. Okay, so let's make those ones. Let GT 0 LT and E. It's gonna be really computationally expensive, but we're gonna get this and we're gonna look at it with our eyes. GT, LT, E, and yeah, this isn't gonna return nothing useful. So let's hit it, and then I might hit it again once I see some valuable things to look at. Okay, 2 beat, there we go. I bet there's a math optimization somewhere in here. I know it. Equal 9240. You're all the same? You're all exactly the same? It's not possible. I mean, hey, at least I know there are 9,240 of them, but what the heck? What's the rules? There's 11 actions long. 5, 3, and then 3. 5, 6, 7, 8, 9, 10, 11. That's 11 for you. I'm gonna look at it with my eye. It's gonna blow up my terminal, but I have to. Yeah, you do it all in memory before you give it to me. Yeah. Could better generator. It's fine. It's fine. Yeah, look at all of them. Look at them all. They all look like they're doing stuff. Give me a... they're not doing enough, obviously. Track length 2024, y'all said you're equal. So if total's greater than to beat, total's less than, so it's else. For some reason it's else. I have to look at them. It's gonna be painful. Not planned, no. Raw changes. I thank you. Yeah, we're still gonna eat that memory smoothie. We'll roll with it though. Anything different? The duel is set for 24 loops. You do this. A valid action plan could be this. They declare, allowing you to take quick note of it. That's not useful. Consider all possible plans. Okay, we should be in logging territory. Man! No, it's Batman! Oh no. So what we're doing is we're adding to total something wrong, which is value starts at 10, which means change, which means changes, change I, changes, plus equals. Come on. Changes. If it's greater than the thing, then go back to 0. It means just at some point we hit it on the undefined. Hey, wait a minute. I don't need to do that. I could just modulo my entire life away. I just realized that. And screw your boring math. Just go for it. I was about to inline it, but that'd be dangerous. If there's a track change, then yes, use the track change. Lots of track changes here. Go for it. So we're gonna look at the numbers too. We're gonna look at everything. Hopefully we don't find Batman again. Are they all Batman? You know what? I'm gonna optimize this. Save myself a life. Well, save myself time, not a life. Drop that in comment. Make a copy of that. Grab that back out of comment. Congratulations, you have one raw change. Please run. Much thanks. Yes, terminate the batch job. Changes an array of undefined. Oh, I'm splitting my comma. Hey, sorry about that. You don't get commas. It's just an array of strings. Okay, good. We good. Drop our fake. Bring back our real. Okay, I think this is going to console log a lot more than we need because we actually have functionality. So let's drop it. And we're looking for how many different winning action plans can you prepare. So the greater than number, right? The ranking A, B, C, D. D wins because that's the biggest number. Okay, I'm feeling confident. And now we have 9,000 more to calculate. Really should put a console on this, on like an iterator on the ever 1000th. Okay, greater than 1172. Dagnabbit. So I already went through looking at uniques. One of them is equal, which is funny. Oh, I generated the exact same one. That's why that one's equal. So that brings me confidence, but the fact that it didn't work brings me sadness. How many different winning action plans can you prepare? These all seem winning to me. So it's possible my track is wrong. That's scary though, because it's kind of difficult to debug. Though they do seem to be following the rule of there's only one character forward, and it does make it to the end. I can look at the end of the track to make sure the last few characters are correct, but that's... boy. So it could be that my calculation is wrong, which makes everything else wrong. Ah, painful. Surprised this is still working. Oh, I know why this wasn't working. Changes was an array of just undefined. Wait. 2024 loops. Yeah, it runs 2024 laps or loops. No example. Painful. Different winning action plans. Okay, I guess I'm looking at the track at this point. Whoa, not during converting a type acquisition. What the heck you on about? Let's have a look. Jeez. I'll just console log the JSON. I'm writing a bit too much Python recently. Okay, so we have negative equal plus equal plus negative equal plus equal plus equal quad negative double equal quad plus. I got it. Okay, the track looks right. And there's nothing aside from visualizing the heck out of this. I can do that. It's gonna be painful. Unfortunately, I'm a little confident that it's not here. So yeah, I have the path. What we want to do, I guess, is path. We have path. Let me just shove it in here. Honestly, it doesn't really matter. Okay, I think this is the way we're going to go and do it. For let I 0 I less than path dot length I plus what we're going to do is going to do all of them up to this point. So cost before equals path dot slice 0 up to I. Congratulations, you're not destructing world. For cost RC of before world RC equals I need a Unicode block. Just give me the square. I think I'll find it on the wiki better. Oh jeez. I should have just stole it from the thing. Should give me the thing. Got it. There you go. Yeah, I don't care about you. Only permits reading. Congratulations, you're on a write. I can write to you now. And then I need to set them off at a delayed paths. Timeout. Console log world I times 500. So that'll be half a second between each one. Console.clear. I think that's the trick. Well, I need to clear and then look at the new world. Okay, let's see if this works. I'm not expecting to see much here, but I'm not seeing where it's went wrong. Jeez, no. Okay, we need to actually spit that out a little better. World.map l.join empty lines. Whoa. Join new lines. Does that look a little better? Okay, here we go. It's all blobby, unfortunately. Oh, I need the world as it is. How do you do the thing? I just made a copy of the world. You know what? Let's just call this one async. No one cares. timeout RI times 500. There we go. Yeah, no one cares. Okay, great. I can see with my eyeballs. Let's bump that up to 150, because I don't want to sit in here forever. Yes, terminate. Let's drop it to 50, 25, because I am not waiting that long. I am not being that computationally freaking expensive, and I just realized it's being exponential. Let's just drop it to always 25, or it's being additive. Dang it, that's not wrong. It's a nice visualization. Y'all just got a little sneak peek with what's going to be happening when I get time. But this isn't wrong. Which means something else is. Okay, I answered 1172 because that's what I found was greater than the ones I hear. How many different winning action plans can you prepare? I've already found this in a set, so they're all already unique. Right? Let me count. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. What are the rules? Just have that many. 5 pluses. 3 of those. 3 of those. What's the one you gave me here? 3 minuses. 1, 2, 3, 4, 5 pluses. 1, 2, 3 equals. Yeah, you did the thing, buddy. Good job. 1172. That is how many have a greater score. Fine. We're just gonna keep all the scores. How about that? Put gained. Y'all go in the thing. Yeah, and your nodes are your plans since they're unique. So, gained for all changes equals total. And then I don't know. Well, this isn't going to help too much, but I'm not really sure what's wrong. These are the tough ones. Might be. I think I'm actually not. Hey, get back here, you mouse. Okay, I just need to write this to a file. Thank you. I'm just gonna dump that real quick. There we go. That should do something. I'm also console logging it, which, it's like 9,000 keys. We got this. I shouldn't say array. I should say sequence. Why is my CPU going? Why the heck did that make it run so fast? Okay, yeah, I mean, we're looking at it here. See a lot being under. And yeah, as expected, these ones all bulk up here, and then, you know, based on the permutation algorithm, they all bunch up elsewhere. And then there's one that matches this, because its input was exactly plus. Okay, come on, give me the real one. Plus double negative plus equal negative double equal triple plus. Yeah, so I found yours. These are all the permutations. These are all the scores. So my scoring algorithm, or the thing that runs it so many times, consider all possible plans, it's gotta be wrong. Am I considering the S? Am I considering the S? Where's the rest of my code? Okay, there it is. Better be considering that S. Okay, just give me the last one. You're gonna be picky like that. I'm considering it twice. Everything is wrong. That's why everything is wrong. Stop running. I need to stop console logging some things. It's always the off by ones, people. Very painful. I am in a great amount of pain. So obvious. Yeah, number has changed. Everything has changed. This is why we write test. Because if there was a test on that track parsing thing, it would have encountered or covered 36 are equal. Gets a little concerning. Well, now what? What did I do in part 2 with the handling of the S? I did something for it. I push an equal sign at the end? Right, because there was no S. Is my S in the front and not at the end? I bet that's where my S is, isn't it? I'm gonna log it, and it's gonna be in the front. Not at the end. Son of a... So I need to go to 1 and -1, and then I'll need to add it back at the end. Stop running. Yeah, so we have a negative. Now, let me not slice that. That could be a good character back there. I don't know. It's the S. Now, this one, actually fine keeping, because that S gets turned into a 0. But this number is going to be different now, too. So I got a 5-minute wait until I get something better than 1012. No, my 2-beat didn't. Wait, my 2-beat from last time. Yeah, 1888. Yep, it already changed. Now, if this doesn't work, I have a little more confidence in the track, but I won't know where to go next. Again, this is my test. Useful. This seems like a much better number. Well, I'm going to put it in there. I could have swore I had a 5 failure. Oh, never mind. Woo! I did it. Ooh, there we go. Okay, I got a little squirrely at the end there, but we did it. So, let's break down the problem from beginning to end. So, the first one, I think we were just... Yeah, we were given 10 segments. So, we were told that for each racer... These are racer or devices. They had a preset number of actions. So much like the last one, each line is a different unit or row or input, starting with the ID, followed by a comma delimited list of the actions. So for each of those, we performed that action, and that action corresponded to adding 1, subtracting 1, and doing a nothing. And what you did it to was the initial score, or the power of 10. And you did it for however many segments there were, 10 initially. Which means you started at 10, you add 1, you get to 11, because you're a plus. And then you subtract 1, because your next change is a minus, to get back to 10. And then you do this 4 times, and then you loop back to your previous action. So this is you can think of this as a cylinder or a circular feed of, hey, as soon as you're done here, your next action was your first action. You keep looping back around until you finished your race, which is 10 segments, which means these first 4 are the first 4, 5, 6, 7, 8 are the same 4 again, and 9 and 10 are the first 2. trick there is to not reset where you start at the end of a race or a segment or whatever. This device next action is always persisted in memory, which doesn't matter for part 1. But for part 1, whatever the power is at the end of each race segment, you sum them all up and you have your final ranking, which is like, hey, you give the string of who came first, second, third, and fourth, and that is determined by highest to lowest. So 116 is Bravo, 110 is Delta, Charlie is next, and Alpha is the lowest. And that corresponding code looks like this. I create a mapping of who's gained what. We go through each line, we split out by the colon to get our node identifier and the role changes. We split those by the comma to get our actual individual characters, and then we turn those into numbers because those are easier to operate on. Then we say our total, which is all of them added together, and our current value. For each segment, we use that segment index to calculate the index of our change using the old modulo operator. So for example, if we got to 8 modulo 4 turns back to 0, so it continually uses math to wrap around within these 4 numbers. Later I just manually increment it, but for here that's what we do for that. We get our change, we add it to our value. Basic math. We store the end result for all of these. We go through the entries, which is an array of tuples, the key and the value. Said tuple is right here, with the key being a string. And I never told TypeScript what the value was, so it's unknown. But we're sorting in a descending order, so that's from highest to lowest. So we grab B minus A, that's how you do highest to lowest. You can think of it as going from B to A, because A to B will be ascending, B to A is a descending order. We do that, then we map over each one, destructure out the node or the key in this entry pair. Just take that and then join the characters together. That's part 1. Part 2 is where they introduced tracks, which very fun. So everything stays the same, but we now have a track where we start on the S, top left corner. We then go to the right, so row 0, column 1, and then we follow it to the next character, which in this part 2 is always just the circumference of the square. And then you go down, then you always end up back at the S, which is a position that you drive on, but you treat it as if it was an equal. And by that, I mean, whenever you drive over a plus, you get the effects of the plus, no matter what you originally were going to in your plan. Same thing for the minus. If you drive over a minus, you are doing a minus. The equals will ignore. So whatever your original plan was, when you see an equal, just do what you're going to do anyway. And that is it. Our segment length is now whatever the length of the track is, so not hard-coded to 10. And the trick is that instead of just going one loop around the track, which is what we were emulating in part 1, we're with n number of segments, we're doing n number of loops. So 10 loops, you just keep going around the track, and you do the exact same adding, calculating, and scoring. This was the cheekiest, jankiest way of just grabbing these characters out of the track string. Since it was a square, I thought I was for part 2. There's no thinking about it. So I just grabbed the first one. I was like, great, all the characters in the first line except for the first character. So that was, visualize it, these characters. And then for the next one, I was like, okay, I'll iterate through every row but the first. So these 2 rows. And I'll grab the last character. So that is this character and that character. And then I was like, okay, I'll take the last row, which is this. I'll grab every character but the last one, so it's these four. I'll reverse it because we're going right to left in this top-down view, and I'll add it. And the last one was similar to before. I'll grab all the rows from bottom to top this time, except the first one. It's a sort of reverse for loop. I'll just grab the 0th character, which is here and a here. So again, it worked. Then I just pushed an equal, which technically represented the S to be the final state, which is what we needed for part 3. But we got there. It's fine. Everything else is the same. I then... Something that worked in part 1 but not part 2 was the fact that you need to, like, what index of, like, your plan is tied to your value, not your lap or anything else. Like, this doesn't reset every lap or something. So I had to move that up, brought that up, did my manual modular resetting to 0 here, and that was it. The only addition to that is that one, and you do 10 laps. Everything else stayed the same. And then we got to part 3. So let me... Oh yeah, also they provided us a hard-coded racetrack for part 2, which was completely factual, but since I never seen this behavior before, it had me all paranoid and like, why do you say the first round? It's like, isn't that for every round? Or isn't this just the racetrack? Which made me paranoid about, oh, was I supposed to change the racetrack as I drove on it? But not here nor there. We got through it. Yeah, now here's where the fun begins. So, game changed a little bit. We're provided a single like action, like a single plan, and then we're told to count how many plans we can generate that are better than this plan. And we're given a rule for what a valid plan looks like: 5 pluses, 3 minuses, 3 equals, and then an example one. And then our lap count is 2024, so a bit higher than 10. So that's, one change. Numbers got big, inputs got big, and then they were like, oh yeah, we're gonna have you parse this little ASCII track diagram out. So if you were being bad and cheating and kind of just doing edges, that's not gonna work anymore. And it didn't. So we'll start with the track since that's the simplest one to do. I went with the simple, just follow the next path. They also made it relatively easy to parse. So we always take these top 2 ones, and then you just go to the next character that isn't the one you just used. So if say we're on this plus, there are 2 ways we can go: backwards or forwards. We know where we just were. So if we're considering going somewhere we just came from, that's considered backwards. We don't go that way. So we go forward, and it works. We go through the entire thing. We visualize that for our sanity, and it's not a bad visualization, honestly. And yeah, gotta make sure that the S, at least for my implementation, is the last one, not the first one. It doesn't show up twice, because that'd be crazy and break all your code. Next thing is basically generating all possible permutations of this. It's probably a fancy, cool mathematical way. Something to do with them giving us strategy first, maybe, but I don't think there's a way to... Excuse me. Let me correct me. There probably is a way, maybe, to not generate all possible permutations. I couldn't think of it in the moment. So that's what I did. I generated all possible permutations and tried them all. The reason I'm not too worried about it is because it literally says consider all possible plans, and that's in bold. So I don't think I went the wrong route. As for how that worked, first we did the parse tracking in code. Parse tracking. which is what I already described, but the code version is we start with R2 until we reach the end, which is the S. We grab where we are. We go in all 4 cardinal directions. If we're trying to go to where we've previously been, we don't. We ignore it. If we've walked off the map or walking into a space, we ignore it. Otherwise, we're walking in a valid direction by the rules of the ASCII diagram. There's only ever one valid direction, thankfully. We push that and we break it and go all over again until we reach that ending state. And then we just get the characters out because we don't need their coordinates for that. So once we have it, we turn them all into numbers, which is all great. Then what we do is we run through the entire track itself and we just see, hey, who's this competitor and what's their value, like what's their score that we gotta beat. Then I kept track of all of these. We only needed to keep track of those that we're greater of, and we go through all possible permutations of the plan. I'll jump into that code in a bit, but we gotta get all permutations. We opted to use modulo directly here because we didn't need to be manually modulo wrapping it over. If it gets 5 billion, then 5 billion modulo 15, it'll do the math for us. And then based on what it is, we increment our counters, we log our counters, and we say, a good job. Now, these permutations, I have done it a few times. I was not in the mood to do a generate all possible permutations leak code, so I just stole it from the internet. Lots of utils libraries come of this. I think Python literally has it built into itertools. I'm not gonna go through this. You can find literally any other leak code, random code wars video of how to generate all permutations of a thing in your favorite language. But this generates all valid permutations. The only changes I made was not to operate on arrays. We operate on strings instead. Lots of optimizations to be done to this. I did it for strings so I could put it in a set to reduce my impact a little bit. I don't know if it really did much, but it worked. When I refactor this, I will make it into a way that it can be used as a generator, which means it'll yield them as the permutations are located, as opposed to just exploding and using up all your memory and then processing. But yeah, that is the problem. I'm going to copy all these back to our main one and get these committed and call it. Let's see, parse track, permute, all these. Okay, and I do have my part 2 and my 3 here. So my part 3 is 4594. There we go. And what was part 2? Already got that in there. Okay, let me just get these things returning numbers now. Yeah, we're not writing anymore. Big fan. And yeah, and I'll refactor afterwards. I'm not going to change anything here. Let's hit the test. Oh, please run. Don't watch, run. Okay, it's being a little... Fans turned on. Man, I know we're not using the most memory efficient here stuff, but jeez, come on, I didn't break all of the code. Let's skip that part 3 since I know it's Mr. Problematic. There we go. Pretend. Oh, never mind. It works. You know what? 25 seconds. Not that bad. I've seen worse. But as you can see, fully functional. Works like a very unoptimized charm. So let's drop our files. Drop that file. Again, I copied all the code back into here. I just didn't need all that laying around. And initial 07 solution. We are good. As always, it was a blast. Hope a thing or two was learned by a person or two. I will see you next time. Hello, hello, hello. Here I am going to optimize my Everybody Codes Quest 7 solution. And this is the one about the racing around the track with the power levels changing, and the dynamic track. Yep. We've already explained this one. Yeah, I'm looking forward to it. Okay, let's see, what did I do? I have a main one, I have a version 2, and I have a version 3, and I got that manual permutator. Yeah, it's going to take a second to refactor. And I even get this path visualizer, which was a nice thing I threw in there. So first, let's make sure it all still works. Oh no. It's either broken or this is a computationally heavy one. Interesting. It's probably the part 3 that's the heavy one. This is good to know, I guess. Okay. Let's abandon that one. And yeah, let's go through our easies. Okay, let's do our one open up. Yep, as expected, I don't have an example for part 3, that's okay. Oh yeah, so part 3 is the problematical one. Let me remember what part 3 is. Oh, it's try literally every single possible variation of plans and then choose the winning one. Right. Let me see how I do that. So, what's this quest 2, not 3? I need to look at 3. So we do this, we do an initial one, and then we go through every one and we see what it came up with. Okay, so it seems like the easiest thing that's going to ease your refactor is this perform a race logic. Like perform a race and return results. And then, yeah, we will go from there because I already have the track parsing pulled out. So let's see, what's this one? Oh, this is a race without a track. Well, technically there is a track, it's just 10 long, and they're all equal signs, so nothing happens. So yeah, let's do a function, race. What are these, chariots? I forgot, what's the lore here? What are they? Chariots. Yeah, race chariots. So what we need is the track, which is just a string array. Well, actually, it's a number array, isn't it? Yeah, it's a number array. Number array, and then that's chariots, not chariots. And then I guess I need chariots. Well, it's not the chariots themselves, it's chariot plans, ranking of the plans. Yeah, I think chariots is sufficient, which is number array. There we go. Okay, so we have this. I'm gonna basically do this. Well, let's actually take part 2 because they're the one actually running on the track. Ooh, how many laps? Okay, that's a conditional. Let's see about that. For a line of notes. Okay, so I guess these are the chariots for chariots. Yeah, so I guess we need a parse chariots function, parse chariots, which is from notes string return notes.split on the new line, and then map line 2 basically this. What do we call these? The note, the name, the ID. We'll go with ID. Dang it. Come on, mouse. There we go. Yep, so ID and then changes. And then we'll call this raw plan. And then return ID raw plan, which we could turn that into an object of just keys and values. But let's start with this. For chariot of chariots. Congratulations, chariots are no longer a number array. You are this thing. So go, be lazy with our types. There we go. So for chariot of chariot, we have chariot ID and raw plan, which isn't raw plan, it's just plan at this point. Love it. And then it's not changes, it's plan. Let's clean up a lot of these. There we go. Drop a lot of that. Then gained ID equals this much, which I didn't destructure, but I can, not IOD ID. And then we return your results. I like this. Oh, stop that. Oh, yeah, again, this extension hasn't transferred all my settings over. Good enough. Okay, so I think this races the chariots. Now I can use this. Not necessarily in quest 1 because there's no track. I can generate a track. I need to pass it the number of laps. So the track, the chariots, lap count. Boom. Let me go check on 2 and 3. Okay, 2, yes, 10 laps. What about 3? 2024 laps. Okay, all good there. Well, actually, hold on. Is it all 2000? Okay, it is all 2024. I'm loving it. So I think for 1, the only addition I'll have to do is I'll have to generate a fake track of like 10 segments with a lap of 1. Which isn't the end of the world. So cost track equals array.from length 10.fill with a bunch of zeros. Boom, we have our track. Const parse chariots, and then const results equals race chariots. I guess I gotta pass the notes. That'd be a crazy idea. The track, the chariots, and the lap count, which is 1 lap, 1 entire lap. You're an array of numbers. Why can't you see that? Okay. You dummy. And then instead of using gained, we can use a results. Yeah, let's just see how it goes. Why not? No space left on device. Oh no, have I? Let me take a quick break, check on that. I am back. Apparently I had a runaway process that was just going absolute nuts in the background. Just kept on trying to update, which caused it to download a new version of the update, and then a fail, and then download a new version of the update, and then a fail. And it wasn't smart enough to clean up the old versions, it was just downloading new ones. So it kind of just ate my computer alive. But let's do this part 1, do this part 2. Part 1's the only one I changed, so that's the only one I'm expecting changes on. Make sure this thing's still on. It is. Don't care about you, GeForce. Okay, so let's see. Call this results, the ID, the total result. And we don't call this value, we call it something like power, right? Yeah, so this is power. Final power? Why do we have two of these? Plan I? No. Step. There we go. Step's part of a plan. I love it. Look at this. Mark has learned. Made sense why things were starting to be unresponsive during that. Can I just not use final power? Oh, right. So you add up what you have at the end of every stage. That gives you your final power. Total power. Right? Collected power. Essence. Total essence gathered. There we go. Okay, I'm liking it. Actually, put that space in there. So these are power. Yeah, these are power. Power level. How many units of essence? Yeah. So power is the change. Yeah, it's the change. Okay, I love it. This is good and for me, and this is just wraparound modulo stuff, which I'm gonna do better with later. We have the racing of chariots. As a result, we can use some types on this to make it a little happier. Record. What are we doing? String number. There we go. Much happier. And rename you to ID. Yep. So we get the track, get the chariots. We do the thing. We race them. Love it. Solve quest 2. So we parse the track. Which we have a cool parser to do that now. We race him 10 times, and then we're good. Okay, let's try that. What's this bit, though? Generate rankings. So this is our string number. And this just does literally this. Love it. Okay, now I'm liking it. First, I guess we'll start with const track equals parse track notes. Nope, not that. Raw track. Yep, let's start getting rid of these bits. I think it's just 10 laps, right? That's all I gotta deal with. So const chariots equals parse chariots notes. Results equals race chariots on the track with the chariots, not a channel splitter mode, for 10 laps. And then we return our generation of rankings. Apparently I didn't type track properly. No, I didn't. Oh, that's right, you're a raw track. Let's do the mapping and that parser. So here, I mean, I do it down here, I guess, right? Track equals track.map. I can put the map here, but I never need the raw track, so it makes sense that you do it down here. Did I paste the right bits? Kinda. What am I using? C. There we go, and yeah, we're gonna optimize that real soon. Don't we worry about it. Okay. Results. Let's see if part 2 is not broken. It's broken. Oh no. Okay, so let's see what we did wrong. So previously, we did our track parsing. Our parsing needs to do things with the S. You're 0. There we go. That might help it. Nope. Okay, more to go. Let's dig into it. Okay, so we build the track, which is just thing with all the characters. I don't think we include the S, so we could be having off by 1 behaviors here on the track generation. Assuming that's not it, we do 10 laps. And then we do the exact same thing at the bottom here. Okay, so track generation is my culprit. Track 2. Electric Boogaloo. Boy, it really hates this. I didn't do anything to you. Oh, it's track 2. Whoop, boop, 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 boop. There we go. Let's see what you spit out. I've already... Unterminated regular expression. Sure, buddy. Whatever you say. Okay, oh yeah, let's get rid of all these. Back to our reel. Okay, track and track 2. Oh, they're different. Absolutely crazy. How could I have ever seen that coming? So track 2 is 11, track is 12. So the parsing of the track actually works for part 3, which makes me think I never actually tried it on part 3, so let me make sure part 3 still works. So we go down and look at the part 3 code, because we're obviously handling the track in some way. S less than track length, S++. S less than S++. I don't think we do anything special. I haven't changed part 3. I have not touched your code. That's not good. Okay, I added the S here. I did technically touch your code. Okay, let's halt the party. Let's get part 3 working again. Parse track, slice 1. And then, yeah, you don't need to do this mapping. Congratulations. I saved it for you. So slice 1 means we skip the first one, which is the S. Okay. Interesting. Let's see if that fixed part 3. If it did, then, well, I know why part 2 isn't working. We're not slicing off the first one. See you in another 30 seconds. I think this is, if I remember correctly, this time is... I mean, it's going to be the same time no matter what, but it's inefficient due to our current permutation generator, which isn't a generator. It's a function that shoves it all in your memory. Boom! Okay, so we need to slice 1 for our part 2. So let's do that. Do our slicing. Because we don't care about the S. There we go. Now if we go into our part 2 with debug, we should see the exact same track. Starts with 1 0 0 1 0 0, ends with 0 -1 0 0 -1 0. Okay, I got it. Yeah, so let's go back to the generation of ranking using the proper and see if that works. As expected. Goodbye, old code. It was nice knowing you. Which means... So yeah, we have this slice that we're doing on all of them. So how do I want to do this? I think we make it... Well, this one's correct. We make it 10. And then I think in the parsing of the track, we slice off the S. If we're doing it everywhere, it makes sense to do it here. There we go. And then we'll have to worry about the actual S, which is something we were doing, and now we don't. So every time we use parse track, we don't need to slice no more. Part 2 will work. I'm not going to run part 3. I'm confident in it. Okay, I'm liking it so far. So we have the parsing of chariots, the racing of chariots. Isn't there something else? Yeah, const. What do we call these things? There we go. Action to change equals action, which is plus, and let's just do some easy stuff. If action, let's use switch case. We don't get to use those too often. Turn -1 case. Whoa, where'd my keyboard go? Turn 0. Yeah, let's inline them. That looks cool. Case plus 1. There we go. So action to change. Love it. And then we can just shove that literally in here. Boop. Why? Oh, because it's a thing of strings. Meh. So let's do. I really want to. I'll try my best. Split, and that just gives you the thing. As action array. Congratulations. Yep, I like that. Where's this other place I'm doing it? Oh, that's not gonna help. It's my track parser. Where is it? Yeah, so I have the racing of chariots. Okay, wherever I parse the track. There you go, little fella. Map. Boop. Nope, that's not it. Action to change. Now I just need to say, hey, don't worry, you're in action, buddy. And an action technically is an S. Yeah, let's. Yeah, casting, nobody cares. Good enough. This is so tempting to keep here. I'm gonna keep this here. I'm gonna add this as a thing at the end. I didn't need that. I do need to also refactor that at some point, but let's make sure everything's still working. There it is. Okay, let's get part 3 of going. So we have our track, we have our initial one to beat, and then we run it for every possible plan. So let's start with the basics. Const track, const to beat chariot, parse chariot's notes. We know there's one, so let's grab it. Const to beat equals object.values race chariot on the track with our to beat chariot lap count 2024, and then what is it, the 0th value? That's my to beat. Let's start chopping away at this. There we go. And then we go through each of them, we erase them, and we find out which one gives us the, well, we just add the counts of which ones are greater than. Okay, so for const plan of generate valid plans. Are these string plans? Or? Yeah, these are string plans. So let's say const changes chariot equals id 0 or 0, whatever, and then our plan, no, plan, change, no, plan, yeah. The problem is this is not a plan, it's a raw plan. There we go, it's raw plan dot, so we'll convert you to an array as action array, and then we'll map you dot map action to change. Whoops, almost lost that one. Now that I have a chariot, I'm gonna put you in the race and see what your value was. So const result equals object.values race chariots on the track. We have 1 chariot and 2024 laps. go. Now, if result greater than 2 beat, let better plan count equals 0. Better plan count, boop boop, and then return better plan count. I think that's what we do here. Yeah, greater than 2024 split map reconvert. Yeah, I'm feeling pretty confident about this one. It's still gonna be your 30 seconds or whatever, but let's send it. And then while this runs, let's start cleaning up some comments. Right, so I have an action. Yes, the thing. Get on my way. TypeScript. Action to change. Parse chariots. We map. We split. Boom. 22 seconds. Shaved a few seconds off. I love it. Yeah, I'm liking this one here. Race chariots. So for every S in the track length, I want this to be something else. Oh, S for segment. Yeah. Segment index. And instead of track change, does not. Let's just leave it as that. Track change, if track change, do the thing, right? I love it. I have to come back for this modulo at some point. Let's do it now. Step equals step plus 1 modulo plan.length. Just going to put these in parentheses. Drop. Make sure part 1 still works. Part 2 still works. Beautiful. That's our way we're getting step to go forward. So we get the change, and then, hey, if there's a track change, use that one instead. Now, I am mathematically doing this, so we might be able to do some cool, funky stuff here. To basically say, if there's a track change, use it, otherwise fall down to the normal change. So I'll call this plan change. Planned change, track change, const change equals change or planned change. Because if this is a 0, it's equal, then it'll fall back to this. But if it's 1 or -1, it'll go to this. In my theory, boom, like so. So we have plan change, we have track change, and we have actual change. Is there a way to do... Okay, I was about to be like, is there a way to cheekily do this inside of here? We can do the forbiddenness, which will be something like this, but then we have to do some decrements of the result to get it back to where it was. So let's not do that. This is something we do every segment. So this is saying it's done at the end. So if we do some cursed for loopage, and we just put it in there, no one's gonna know. Yeah, it's a little cursed. That's fine. Well, it allows us to make this... it's cursed. There's no way about it. Add to that, which means we can, if we really want to go for it. There we go. Let's make it super unreadable, why don't we? It's not the worst. I've seen worse. Okay, so we have the racing of chariots that generates our rankings. The 1, the 2. Yeah, these do need to be different because 1 doesn't have a track. The permutator. Yeah, we're gonna talk to you. Never mind. We're talking to you literally right now. Wait, we could do track parsing maybe a little better. But yeah, let's get that one. And let's keep that one because I want to actually visualize it a tad. Okay, so we're at the world. We need coordinates and we need our character. Yes, we need the character to know if we're at the end. Then we need our next one because that's how we do our previous lookups. We have our current position, we have all our directions, we have all our places. We look at the one before us. Okay, so I've made an array of objects. I could just make one really big object, effectively a linked list, given that this is linear. This would make this lookup less painful. It'd be a different way of doing it. Memory's about the same. Still that many number of objects. This lookup honestly isn't that expensive. Do I need these exclamation marks? I don't. I'm not in strict TypeScript mode apparently. So path at -1. This is basically saying current. Then we have row offset, column offset, new row, new column. If you are looking at the previous one, ignore it. If you're bad, ignore it. If you're good, we found you. Stop the presses. And for this, we map and we map. We can just single map. Go. And what are this? This is, what are these? What are these? Segments? Segments. I didn't rename it though. Segment. There we go. Segment.s, and s is not that. It is character, or go C at least. Well, nope, no go C. We're using that character. Or we're using that variable for something else. Oh, nice. We'll get to drop that. Yeah, I think this is sufficient for here. So yeah, the only one remaining is our permutator. Now, we're doing a lot of stuff here. So the trick about this is that I don't want to see duplicates, yet I would also like to turn this into a real generator. So let's see if we can just find that. Permutate. So that's a unique permutator. Without duplicate and fixed length. That is true. Okay. And does that work? Here's the thing, I have multiples though, so I don't know if that's gonna do what I want, but I'm always down to try. Let's get this in here and run this real quick. So yeah, we're seeing all the things. Let's do it on mine, which is right here, and see if we see duplicates. Fixed length of 3. Fixed length is of 11, I believe, which is all of them. It's going to be a big one. Or it's not. We're not going to see any. What did I do? So we have a big pool, and then we have... Okay, if I go to 10, will that make it right? Then be a lot of duplicates. Yes, I don't think there's a way out of this without keeping track of ones that I've seen out. Generate valid plans 2. Let's make this a generator, which I think we put it there. There we go. So I want to do this, but instead of doing it on the call stack, I think I'll just do it in memory. That'll allow me to do my yield calls. I mean, I technically can yield from this. Yeah, okay, let's just try this. Boop, boop, boop. So our array, if length equals 0, if result.has m, return otherwise, and then we yield m. Yep, so congratulations, you now also, how do we make an arrow function one of these? We don't. We can. I won't. Okay, and then what's the yield from bit? JS yield star. Okay. Cannot find input array. I haven't made it. That's why. It's computationally, like I said, identical, but we can get the results back quicker and just not be waiting for all the memory to fill up. We're still filling up some memory, but we can go quicker. We're not reliant on that memory. Generate valid plans too. So whatever we're calling this, boop, just call it there. And the tricky part is we don't have a small. Boom. Okay, it hates that. So my assumption is that this of would iterate through all the bits. So I'm either not iterating through all of them, or ooh, I'm returning. Is that illegal? I mean, yeah, that's legal. Ah, here we go. Yield star. Yep, gotta yield from them too, buddy. Gotta do the yield train. Everyone yielding. What we could do is we could allow the generation of duplicates and then just be like, hey, we've already seen you, chariot. Because technically we have two things in memories with all the chariot keys. Ooh, okay, so we're not really that much faster. Oh, and we're wrong, too. Jeez Louise. Okay, so I did I changed my permutation to be like, let's ignore the duplicates. What if we're just like, fine, we'll take your duplicates. Where'd they go? Where'd it go? I've lost it. No, it's not there. Here it is. Right. This is the right one, yep. So yeah, it's gonna go more, but it'll be fine. I'm gonna move ahead assuming I get this working. So basically it's two places. We're not even keeping the result here. So yeah, we don't have two places. We're just doing it in the one. Interesting. It's obviously going through a lot of them. Oh yeah, we're doing a lot more now because we're not using the advantage of the set. Yikes. Yeah, it's gonna go on forever. Let's reload the window. I think I'll target the count. So we can see how many there were. So let's just boom, generate normal valid plans. Let's just see how many we hit. Then my theory is to bump it to 2 and see how many it hits. Actually, bring that terminal back. 30 seconds. Obviously, I'm doing this the slowest possible way. Yeah, some efficient way would probably be ignoring the value on positions with an equal sign, right? But so basically be like, okay, what percentage of this index in my plan would be overridden by an equal sign? So you'd be analyzing the track and using that to determine which ones you go for initially, or even at all. I could see a way. Hey, terminal, tell me 1940. No, it's 9240. And with my new fancy yieldy one, it's gonna be less, obviously, because it's a broken. Is this return breaking the thing? Maybe I just need to flip it, because I think the return keyword might be doing some funky stuff with the iterator itself. Yeah, obviously not enough. 92 for what? We kept the same amount, but we that's terrifying. That is terrifying. Run length equals 0. Let's also just make it a little prettier. Nope. That means I'm yielding different values, which means I might not be yielding the plans. I might be yielding bits of it, like individual one character longs. So I need to get into it. There we go. And actually see what plans are being spat out. Oh, come on. The whole point of this is that you'd start spitting them out quicker, not wait an eternity. Yield. Oh, is it building all of them up first and then it starts returning them at the end? Oh, it is what it is. I just want to see the plans. Give plan. No, I can just jump in right here. Or not. Did you not hear my breakpoint? Where are we going? Yeah, it didn't. Where's my debugging? How dare you? Okay, let's put a breakpoint there. Ignore me now. I think I hit it on the wrong one, now that I'm thinking. It is this function. Yes, it is. I didn't change that much recently. Oh, whoops. I made an infinite loop by removing those, that else. That's on me. Once more, into the fray. Debug. Okay, finally. Oh no, I had put a breakpoint somewhere, didn't I? Yeah, it's right here. It's literally right here. Where did you go? I got rid of the bad code. I got rid of it. Oh, hey, at least it cancels. That's good. Okay, finally, I made it. We're parsing the track? Did I break track parsing? Column 70. You don't have... Do you have 70 columns? Okay, let's look at path 194. When did I break path track parsing? I never touched this. Did I put a character in the track? Oh no. Oh no. Dang it. It was me. The fool was I. Ah. Dang it. Okay. Yeah, look at that. It works. Okay, I just want to see the plans. Sure, let's go for it. Just show me the plans. I just want to see a plan. Raw plan. Yeah, that's a good looking plan. These are all good looking plans. It might just work now. I don't know how long that bug has been sitting around mucking everything up. 9240 is what I'm looking for. No, it's saying the number is less. But when I use the old plan generator, it works. How many did I generate? 9240. You know what? It's not really the problem at hand. So I'm fine for just using the old permutator. Wanted to be fancy. But even being fancy, we still go through the entire thing. The only optimization we're not getting is that we're waiting for all of them before we go, which is fine. Make sure this still works. Track parsing, still good with it. Generate plane, permutator, the 3 quests. Yeah, let's bring these down, our stars of the show. And yeah, parse track, get out of here. I mean, you're important, but not right now. Let's hit all 3 of them. And yeah, let's bring this out. Visualize track parsing TS. I thought this looked nice, so we're gonna keep it. Make a tiny little standalone thing. Doesn't really do too much. But yeah, visualize track parsing. Yeah, we're not actually doing anything here. Yeah, visualize the path. Now we're just gonna do this for all the tracks that we have, which are 2. All 2 tracks. For const track of an array multi-line strings. Yeah, let's get that last one. Boop. And then it'd be where I fix the rest of it, because everything just broke, apparently. Part 2 is down. What did I do to break part 2? You're just parsing, racing, and doing... Broke the track parser again, did I? Well, maybe we can get rid of this part now, at least. Or did I break the track itself? Nope, no changes. Jeez Louise. It's 1 at least still working. Okay. That's something. BDCA. Let's look at the generated track. Track is 12. Undefined. What? These are the S's. I understand that. Dang it. I didn't update all these, so that's been broken for a hot minute. I was thinking if that was breaking my permutator. I believe not. Okay, now that we have this finally working again, we can go back to having our fun. Can I... Can I do some top-level weights in this file is my only question. CD 2024, CD... Where are we going? 07, MTXTSX, visualize... Oh no, don't look happy. Oh wait, it's not supported. Okay, what we can do is we can just do some cheeky stuff. Well, promise resolve. No. We'll just keep chaining it on. So, prom, then... Oh, come on. And then what do we want to say to this? Parse, track. That should work. I don't know. Let's await that, sync that. Yes, we generate it, we visualize it. I think this is good. It's a promise returning a promise. Yeah, let's give this a shot. Dang it. Nope, don't do that. Give me space, don't do that. There we go. Now let's look at it with our eyes. Yeah, look at her go. Might be going a little too fast. I'm seeing that flashing in the top left. But it's a visualizing. Yeah, that's all I wanted to do. Just wanted to visualize it a little bit. 25. Let's bump it up to 33. Still flashy. 50. Okay, I might not be able to get rid of it. Yes, terminate the batch job. Okay, yeah, that's just part of the life. Okay, but this is the extra cherry on top I wanted to do. So let's look at our final changes. They're all passing. Yeah, let's one last step through. So for all of them, we start off, for most of them. So this one, we just generate a track of 10 length that does nothing. We parse all our chariots, which is going line by line, splitting out the ID of the chariot from its plan, taking each plan, splitting that into its characters, mapping each character to a numerical actual change, 1 for plus, a -1 for minus, 0 for equals, then returning that object to use later. And then we do the racing of chariots, which takes the track, all the chariots, and the number of laps. For each chariot, we race them one by one, so there's a sequential race, so it's a weird race to watch, but it is what it is. If I were to visualize this, they'd all obviously be run in parallel, but we ain't doing that right now. So we keep track of the total essence gathered for this chariot, its initial power or its current power, and the step of its plan it's on. We go through each lap, we go through the index of each segment of the track, while additionally incrementing the current step we're on. Hold on. Nope, we don't need this. There we go. So for cost segment of track, just realize we don't use segment I anywhere but actually accessing the thing. So this is segment, but this is segment change. There we go. And we'll just have our thing here. Do we need the number of laps? We don't. This is just a loop that runs this many times, so let's just change it to an underscore, because it's just do this X many of times. Love it. And you know, I can do this as a while loop. While what? No, let's go through that way. Right, and then after we do the entire race, we are like, how many S's did you gather, buddy? We put it in a mapping, and we'll return that map. When we are racing multiple chariots, we can then take that map and generate the rankings, which is going through each of the pairs and sorting them by largest to smallest essence gathered. And then based on that order, we're getting the ID of each and joining them as a single string. Quest 2, we're given a track. That's it. So we actually do parsing of the track, which I explained previously, but we always start top left and we always go to the right, so that makes it easy. And then until we have reached the end, we get where we're currently at. We try to go in all 4 cardinal directions. We generate our new coordinate in that direction. We check if it's the one right before us, so if it's the previous one. If it is, we skip it because we don't want to go backwards. Otherwise, we see where it is. If it's off the map, which would be this not char, because we have our optional chaining to make it become undefined if it's an invalid row. Or if it's a space, then we ignore it. We only want to go places with an actual character in it. And then once we find a place to go, we add that to the end of our path and we break, because there's only one valid direction to go at any point. Finally, we take the path, we get rid of the starting bit, because that is not cool with our calculations. We turn each segment's character into a numerical action, and then we return that array of numerical actions. Then we do parsing, then we do racing. The only other difference that part 2 has is that they are 10 laps instead of 1. And then we get to quest 3, in which we do all the same stuff, but we're given a single chariot, and we're told he's the one we gotta beat. We gotta beat that chariot's score. And then we generate every other possible score using a permutator out of the box. Turn that into a chariot, see what its race results are. If it beats the one we're supposed to beat, then we're good. And we add it to our count to see how many beat the plan we were given. I think that is basically it. Optimize 07 solution. And yeah, that is the refactoring. Apparently I haven't saved it. For everybody codes. Quest 7. Pleasure as always.